Hi, welcome to this video. This is 3A-3. We're going to talk about the 6 trigonometric ratios of an angle. Yes, there are 6, not just sine, cosine, and tangent. There are other 3, which are reciprocal functions. So that's our learning target. We're going to talk about what the 6 trigonometric functions are, and you'll be successful if you can name the 3 primary trig ratios and their corresponding reciprocal trig ratios, as well as you can determine the 6 trig ratios of an angle in simplest form. So you are probably already know the main 3 trig ratios, sine, cosine, and tangent, and how to find them from a right triangle. Given acute angle theta, you have a side that's opposite of the angle. The hypotenuse is always the longest side that's opposite from the right angle, and then you have your side adjacent. Sine of theta is going to be the ratio of the side that's opposite divided by the hypotenuse. Cosine is the ratio of the side adjacent divided by the hypotenuse, and tangent is the ratio of the side that's opposite divided by adjacent, right? SOHCAHTOA. That's the main way that we remember this, and I always tell my students, go ahead and write SOHCAHTOA like this. So if you're ever working on a problem that involves SOHCAHTOA, make sure you just jot this down, and it helps you remember, one, the relationship of the ratios and the sides, as well as, what side goes on top, so on and so forth. Now, there are 3 other trig functions that are reciprocals of sine, cosine, and tangent. If I just take this relationship, right, opposite over hypotenuse, if I just take the reciprocal, if I flip it, same with cosine and tangent. These reciprocal trig ratios are cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. So CSC, SEC, or sec, and then cotangent, cot. So that's what some people will pronounce these as, but these are the reciprocals, meaning I just flip the ratio of sine, cosine, and tangent. So sine opposite over hypotenuse, its reciprocal is cosecant. That's going to be hypotenuse over opposite. Cosine, its reciprocal is secant. So we have hypotenuse over adjacent. I just flip those, right? Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And then tangent, it's not inverse, it's reciprocal, very important distinction, is adjacent over opposite. So again, we just flip those 2 sides. The relationship, the way I remember it, is that these are always paired with a co-partner. So sine, its reciprocal is a co, so that's cosecant. Cosine is already a co, so its reciprocal is secant. And then tangent, this one actually just matches, it's cotangent, okay? And another way that you may see these written as looks like this. Cosecant is 1 over sine. Or vice versa, right? Sine of theta is equal to 1 over cosecant of theta. Secant theta is equal to 1 over cosine, and cotangent is equal to 1 over tan theta. So those are the big 6 trig ratios: sine, cosine, tangent, cosecant, secant, and cotangent. Okay, make sure you can name them and their relationship to each other. So let's go ahead and vary it in practice. That's what this lesson really is about. It says find the 6 trig ratios of an angle theta in simplest form. So again, with right triangle problems, I always recommend labeling. Like if this is theta, here's the hypotenuse, this side's going to be opposite, and this side's going to be tangent. And then I want to go ahead and I want to find, okay, what is sine of theta? Well, SOHCAHTOA. Oh my gosh, I already forgot, guys. Can you tell I already forgot? Watch me actually make a mistake. Tangent, opposite over adjacent. Okay, so I like to write that down. It just helps me remember, okay? And it takes like 2 seconds. So useful. Opposite over hypotenuse. So 4/5, that's sine theta. Okay, how about cosine? I'll try to do my best to accurately color code this for you. Adjacent over hypotenuse. Did I write tan? Why did I write tan there? I meant to write adjacent, ADJ. Okay, and then lastly we have tan theta. Tan theta is opposite over adjacent, so 4/3. Okay, let's go ahead and do the reciprocals. So the reciprocal of sine is cosecant. So cosecant theta, it's the reciprocal. It's 5/4. 5/4. The reciprocal of cosine is secant, S-E-C, of theta, and that is equal to 5/3. And tangent, the reciprocal of that is going to be cotangent. We'll just use blue. That's going to be 3/4. There you go. Pretty easy. Okay, the main 6 and just practicing how we get them. Here's a practice problem. Please pause me. Double check your work here. Boom. There you go. Did you get these values? Remember, theta, the opposite side is going to be the side directly opposite. Hypotenuse is always hypotenuse. This side, opposite and adjacent, will change, right? If my theta was up here, the angle I'm looking at is up here, then 12 is going to be opposite. So it really depends. Opposite and adjacent will change, okay? So anyway, you should have gotten those values. Cosecant of theta, 13/5. Secant theta, 13/12. Cotangent, 12/5. Okay, how can we make this more difficult? Well, we can first start by adding in some radicals, square root of 13, which comes with rationalization. So you may see an answer where we don't have the radical in the denominator. We'll talk about that. So let's go ahead and start by identifying our angle and then labeling. Here is the side opposite. Hypotenuse is our radical, and our adjacent side here is 2. Okay, sine of theta, we'll go ahead and start. Sine of theta, that's going to be opposite over hypotenuse. So we get 3 over the square root of 13. And lo and behold, we do have to rationalize. You might not see that answer written this way. You might see it written as 3 square root of 13 over 13. And the reason for this is mathematicians a long time ago didn't have calculators, and they don't like dividing by an irrational number, something that's not finite. I can't put it into square root of 13 groups. So we would rationalize. We'd multiply by a square root of 13 value, and therefore our denominator is not an irrational number. When we get to calculus, we don't care if our answers look like this. Precalculus, you may or may not see it. You know, it kind of looks like this. But anyway, this process of technique is called rationalizing the denominator. You multiply by the radical that's in the denominator to the numerator and denominator. I can't change numbers willy-nilly, but I can use some math tricks where I multiply by 1. I didn't change it. I multiplied by 1. Okay, but it changes its outlook. Anyway, that's rationalizing. So let's go ahead and do the same thing for cosine of theta. Cosine of theta is going to be 2 divided by the square root of 13, adjacent over hypotenuse. And again, if I rationalize, what we end up with is 2 square root of 13 divided by 13. And that's kind of the pattern here, is that you're going to multiply that radical into the numerator. You're going to get rid of the radical in the denominator. That's what happens when you rationalize. That's the shortcut, if you will. Okay, tan theta, I don't think this one uses that radical, so we're golden here. 3 divided by 2, opposite over adjacent, TOA. Okay, next, let's go ahead and do the reciprocals. I'm going to be smart about what form I use for the reciprocals. Cosecant theta, its reciprocal is sine, and so I'm going to take the reciprocal of this answer, but I'm not going to use this because then I have a radical in the denominator. I'm going to use my first version. I'm just going to take the square root of 13 over 3, and I don't have to rationalize anything. Hey, that's beautiful. Okay, and then SEC, secant theta, is the reciprocal of cosine square root of 13 over 2. And then last but not least, cotangent of theta, 2/3. Okay, there you go. Pretty straightforward, pretty simple. I have a practice problem here. Go ahead, pause me, try this one, and then double check the results. Okay, here you go. Square root of 11 over 6 is sine theta. Cosine theta is 5 over 6. Tan theta is root 11 over 5. Cosecant of theta is the first time you have to rationalize. You should have gotten 6 over square root of 11, but if you multiply top and bottom by square root of 11, we get 6 square root of 11 over 11. Secant theta, 6 over 5. Cotangent of theta is equal to 5 root 11 over 11. Okay, how'd you do? Not too bad. That is good. Okay, we got a couple of examples that that can be thrown at you to make this just a little bit more difficult, and that is if we ask the same question but we withhold a side, missing a side. Okay, if I'm missing a side, I can go ahead and I can use my friend the Pythagorean theorem. And the Pythagorean theorem, a very, very useful tool to use. It will definitely probably be assessed on an SAT or CASP, which is, like state testing. Very, very common and important tool. Fun fact, I did actually use this when I was trying to figure out how much string of light bulbs to put on my house, Christmas lights. I didn't want to go up and measure the distance from the apex, so I just did some math and I figured out that distance. Maybe because I'm a nerd. But anyway, Pythagorean theorem, a squared plus b squared equals c squared, where c is your hypotenuse. So c in this case must be 4. Doesn't matter what 3 is. I'll put 3 here. A and b can be changed out, but we're going to go ahead and figure out what this a side is. So a squared is going to be equal to 4 squared minus 3 squared, and then we take a square root of that. So square root of 4 squared minus 3 squared, which gives us what? 7? Root 7 is what this value is. Square root of 7. Okay, let's go ahead and figure out our values. So sine of theta, where's theta? Theta's right here. So this is opposite. Root 7 is going to be our adjacent side. So 3/4 is your sine of theta. Cosine of theta. We have our radical. Radical dude. Who knew irrational numbers were hippies? Radical dude. Square root of 7 over 4. Or maybe surfers. Who knew? Tan theta. Tan theta, opposite over adjacent. Here's where we're going to have to go ahead and rationalize. But you know what? I know all the tricks of the trade. Very easy. Just move it up to the top to get rid of that radical. That's rationalizing. Okay, and then let's check out cosecant of theta. Reciprocal of sine. 4/3. Hey, pretty easy. Secant theta, we're going to have to do some rationalization here. 4 over root 7 will multiply. This is rationalization again if you're like, what the heck is he talking about? Multiply by that radical in the denominator because it will cancel. We get square root of 49 in the denominator, which is just 7. So 4 root 7 over 7, right? And then we have cotan. Cotan, that is the square root of 7 over 3. Again, I just used this first one here and flipped it. Okay? Boom. There it is. The bell. That's, the only new wrinkle. Here's a practice problem. Try this one. We'll go ahead and look at the results here. Okay, here you go. These are the values that you should have gotten. Finding your missing side is the square root of 21 using Pythagorean theorem. You just have to make sure that your isolated value and your initial setup, your C value is 5. That's the hypotenuse. I went ahead and I did it differently than I did in that last one. I just used the powers first and then subtracted and then did a square root, okay? Again, taking a square root, we don't use the positive negative square root of 21 because we're dealing with actual distance, so we won't have a negative root. But here's your values, okay? So, did you get it? All right, hopefully you did. Okay, here is the last way that we're going to go ahead and make this question more difficult. Again, we're given a missing side here. So here I'm missing my hypotenuse. So my A value is going to be 2, my B value is going to be 4, and this is equal to C squared. So I can go ahead and we get 4 plus 16 equals C squared, which means that C is equal to the square root of 20. 4 plus 16. Now, 20 actually has a perfect square in it. That's 4. Square root of 4 times square root of 5. So we're going to simplify this out. This is 2 square root of 5. Okay, so hey, I had to use Pythagorean theorem. I had to simplify the radical. And now we're going to go ahead and find these values. And this will require some reducing. Hopefully you notice, hey, look, they're all multiples of 2. You could actually make your life easier right now and just reduce everything by 2. And then you won't have to reduce. But what fun would that be? What fun would that be? Sine theta, opposite over hypotenuse. Here's opposite. Here's hypotenuse. Here is adjacent. So we get 2 over 2 root 5. I'm going to reduce. This is 1 over root 5, which after rationalizing, we get square root of 5 over 5. So I just reduce by 2, right? Divide both by 2. And then I rationalize. So multiply both by square root of 5. Cosine theta, we get 4 over 2 root 5. We can reduce to give us 2 over square root of 5, and then we get 2 root 5 over 5. Tan theta, opposite over adjacent, 2/4. Do I have to reduce? Yes. Cosecant theta. Okay, now we're getting into our reciprocals. I'm just going to go ahead and I'm going to take the simplest form. Looks like here I reduced, right? And so I'm going to use this form, the reciprocal here. That's just square root of 5. The reciprocal of sine. Secant, what's its reciprocal function? Did you say cosine? Very good. And I'm going to take this form, right? I already reduced, so I have square root of 5 over 2. And last but not least, cotangent of theta, the reciprocal of tangent, which is just going to be 2. Okay? So there you go. Not a lot of difficulty. Here is the last practice problem. Please go ahead, pause. I'll unpause it just to show you the hypotenuse here, and then I'll show you the results. Okay, here's your missing side. I did Pythagorean theorem set it equal to this missing side. And we get the square root of 90. 9 plus 81, square root of 90. So this is 3 root 10. Okay, so go ahead, pause me, and we'll check our results here. Okay, here are the values that you should have gotten. Sine of theta, 3 root 10 over 10. Cosine theta, square root of 10 over 10. Tangent of theta is 3. Cosecant theta is root 10 over 3. We just take the reciprocal of this reduced form. Secant theta is square root of 10. I did the same thing I did here. And cotangent of theta is 1/3. I take the reciprocal of 3. That's going to do it for this video. Hopefully in this video you were able to identify the 6 trigonometric ratios, sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent respectively. All right, give this video a thumbs up if you learned something. I'll see you in the next one. Peace out.